Hey Math 3 kiddos, it's Miss Winstead. So in case you guys were out this week on spring break or you just didn't feel good about what we did this week, then hopefully this video is going to help you. I'm going to take you through what we did on Monday and Tuesday, and then your homework and your review sheet should help you a little bit. So if you have any questions, feel free to email me. You know how to get in touch with me. But other than that, hopefully this will keep you from having to sit for hours with me next week and go through what you missed. So we're going to start out with multiplying polynomials, which is in your notes packet. This actually is not that different from just regular FOILing. So this very first one, we're just going to multiply each term in the first polynomial by each term in the second polynomial. So 3x times negative 2x squared is negative 6x to the third. 3x times negative 3x is negative 9x squared. And 3x times negative 9 is negative 27, okay? And then if we do negative 5 times all of these, we get negative 5 times negative 2x squared, which is 10x squared. Negative 5 times negative 3x, which is positive 15x. And then negative 5 times negative 9, which is positive 45. So then all you have to do is combine your like terms. So don't have any other cubic terms. Negative 9x squared plus 10x squared is positive x squared. Nothing combines with 15x. We're going to leave that alone. And then negative 27 plus 45 is 18. So that should be your answer right there. Okay, so that one's not too bad. If you choose to try this one, you're just going to multiply 3x times x minus 4 first, and then times x plus 7. So if you do that, you're going to get 3x squared, and then 3x minus 4 is negative 12x. So we've done the first part. We still need to multiply that x by x plus 7. So we're going to do 3x times x first. I'm sorry, 3x squared times x, which is 3x cubed. Then 3x squared times 7, which is 21x squared. Negative 12x times x is negative 12x squared, and then negative 12x times 7 is negative 84x. Okay, so combine like terms, 3x to the third. 21 minus 12 would be 9 minus 84x. So that would be your final answer right there. Okay, all right. Where it gets tricky is if somebody asks you, hint, hint, nudge, nudge, to multiply x times maybe x plus 3 squared, okay? So then you would need to know that you have to multiply x times x plus 3 times x plus 3, okay? So this isn't going to be any different than what we just did, except you're going to multiply x times x plus 3 first, and then whatever you get there, you multiply by x plus 3 again. So you just have to know that when you've got a squared right here, that means that you're going to have to write that twice, okay? All right, so this is the part where we get to apply what we just learned. So a metal worker wants to make an open box from a 12 by 16 inch of sheet metal by cutting equal squares from each corner. So I'll actually show you what we're talking about on Post-it notes. So we'll pretend that this is actually 12 by 16. Okay, somebody's tardy pass. So it'll be 16 inches long and it'll be 12 inches tall. Okay, and the metal worker is cutting squares from each corner to make it into a box. So he's cutting a square from this corner. Not going to be perfect at all. Square from this corner, square from this corner, and a square from this corner. Okay. And the reason he's doing that is because when he folds up the sides, like here, 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 and here, he made a box. Now, a box doesn't have a top, obviously, but it would be something like a shadow box or like a little bowl or something like that. So that's what he's using. So if that gives you a visual, then hopefully that's helpful. So we're starting out with our picture. So I've got 16 inches here and I've got 12 inches here. Okay, and I cut squares out like this. Okay, so I started out with 16 along in here, but I cut a little length from each corner, and since they're all squares, they all have the same little length. And I don't really know what distance I tore, so we're gonna make that X. So now this distance along in here is 16 minus 2x because I cut these two x's out. Okay, and this distance along in here was 12, but I cut these two x's out, so now this right here is 12 minus 2x. Okay, and then remember with your box, your height is just the same as the length of the corner you cut out, because when I folded my box up, all of a sudden that's how tall it is, right? So that means your height is just x. So when you write your function for the volume of your box, you've got your length, 16 minus 2x, times your width, which is 12 minus 2x, times your height, which is just x. Okay? So volume is length times width times height. Okay? All three of those right there. So what they want us to do is find the maximum volume of the box and the side length of the cutout squares that generates that volume. So this doesn't have to be very complicated. All we're going to do is take that equation right there and plug it into the y equals on your calculator. So we've got 16 minus 2x times 12 minus 2x times x. And then we're going to graph it. Now, when you graph it, it's not going to show up in a normal window. So the best window to use goes from negative 10 to 10 for your x, and then from negative 100 to 300 for your y max. So when you graph it, it looks like this. Beautiful little cubic function there. All right, and so when you sketch it on your graph, I'm just going to do a rough sketch. It doesn't need to be perfect. Something like that. Okay, so it's going to look kind of like that. So what's really important here about this cubic function is that it has this thing called a relative maximum. And a relative minimum. Okay, and the reason these are called relative maximum and minimum is because this function actually does not really have a maximum, right? Because this side keeps going on forever, and this side keeps going on forever as well. So it doesn't really have a minimum either. But we do have these little hills in our function that function as relative maximum and minimum. So if I ask you what those are just points. So the way we're going to find those on our calculator, second trace. Number 4 is maximum. So left bound's over here. Right bound's over here. So my maximum is at 2.26 and 194.07 if you round. So that represents the side length that I cut out from my box and the maximum volume that I can get if I cut out squares from each corner. Okay? So your actual answer going to be 2.27 if you round. I'm sorry, 2.26 because you don't round that one up, and then 194.07. So this is your side length, and this is your volume. Okay? Side length and volume. So they asked you side length and the volume that generates the biggest volume of the box. This would be your answer. So you found that by finding the relative maximum of your function. Okay? All right. So next page. All right. We're going to skip over the practical domain and practical range for this problem. As long as you understand the previous problem, I think that you're going to be okay. So, all right. Let's go on to Pascal's triangle. We skipped the last two in class also, so you didn't miss anything by not going through those. All right, so Pascal's triangle, it's actually kind of fun. It's a way to expand binomials without multiplying. or foiling. Okay, so it actually makes your life a whole lot easier than it would be normally. So the first thing you want to do is draw your triangle. Okay? All right. So the only thing you have to remember about the actual Pascal's triangle is that it starts out with a 1 and then a 1 and a 1 right below it. Okay, that's all you have to remember. From there, it's just adding to get the rest of the triangle. So we got 1s on the outside always, but then I'm going to add these two together right here to get the number that goes here. So 1 plus 1 is 2. And I get 1 here. Okay, start with another 1 out here. Add 1 and 2 together to get 3. Add 2 and 1 together to get 3. And then 1 like that. And keep going. You get 1, 4, 6, 4, 1. Keep going. You get 1, 5, 10, 10, 5, 1 like that. So you can keep going obviously forever, but that's all we're going to need for right now. So I'm going to label my rows. This is row 1 up here, row 2, row 3, row 4, row 5, and row 6, just like that. Okay? All right. So instead of, well, I'll do the first one. Why not? All right. So the very first one that we're going to do is this a plus b to the 5th. So here's your first step. I'll leave some space up here to write your steps. So step 1, add your degree plus 1 to get your number of terms and row number. Okay? All right, so that's what we're doing first. So we've got this 5 down here. So if I take 5 plus 1, I get 6. So that means I'm using 6 terms, and I'm using the 6th row. Okay? All right, step 2, put in your sandwich pieces, which I'll understand what that means right now, actually. So your sandwich pieces are just your 2 terms that are in here, so A and B. If we were doing this problem, which we will in a second, it's just 2x and 4. So we're going to put in A down here, and we're going to put in B all the way down here, and I like to leave myself a lot of space because these can get a little bit big. Okay, and then step 3 is to put in your other terms. Okay, so we've already decided that we need 6 terms, right? And I only have 2 right now. So the way I'm going to create the other 4 is by multiplying my 2 terms together, A and B here in the middle. So we got A times B, A times B, A times B, and A times B like that. Okay? All right, now step 4 is to put in your exponents. Okay, and in each one of these terms, your exponents need to add up to whatever your exponent is right here. So it needs to be no more than 5. So A is going to be to the 5th power for your first sandwich term. But in your second sandwich term, it's going to be to the 4th power, and then to the 3rd power, then to the 2nd, and then to the 1st. And then you don't have any A's down here, obviously. Okay. So for your B's, you're going to start off in the other direction. This one will be to the 5th power, 4th, 3rd, 2nd, 1st. So you just go backwards that way. Okay, and if you count up your exponents in each one of these terms, they all add up to 5. So you know you've done it right. Okay, your step 5 is to put in your coefficients from the triangle, then simplify. Okay? All right, so our coefficients come from the triangle, and we already said we're using row 6. We're going to use this row right here, 1, 5, 10, 10, 5, 1. So we're going to put a 1 in front of this term, a 5 in front of this one, 10, 10, 5, 1. Okay? All right, so last step is going to be to simplify. Okay, so do your exponents first. This is a to the 5th times 1, which is just a to the 5th. Okay, we've got 5 times a to the 4th, b to the 1st, positive. Okay, then we've got 10 a to the 3rd, b to the 2nd, and 10 a to the 2nd, b to the 3rd, 5a b to the 4th, and b to the 5th. So this is your final answer right here. Okay, so not too bad, and you can apply it to pretty much any binomial. It's just a little lengthy in the process, but it's a lot faster than foiling that out, a plus b times a plus b times a plus b, on and on and on. So trust the process. All right, so let's do another one. Let's do example 7. We've got some different numbers this time. All right, so first step is to put in your, first step is to take your exponent. 3 plus 1 is 4. So you know you have 4 terms, and you're using the 4th row. Okay. All right, so we're going to put in our sandwich pieces, which are 2x and 4. Okay, and then because I'm using 4 terms, I need to create 2 more terms here in the middle, which I'm going to use create by doing 2x times 4 and 2x times 4 right here. Okay. All right, then I need to put in my exponents. So I'm going to start, remember all your exponents have to add up to 3. So 3, 2, 1, and then none of them down here. Then 3, 2, 1, none of them down there. Okay. All right, so I've got my exponents in, and my last step before I simplify is going to be to put in my coefficients from Pascal's triangle. So I said I'm using the 4th row, which means I need to use 1, 3, 3, 1. So I'm going to put a 1 in front here, 3 in front here, 3 here, 1 here, just like that. Okay. So now all I'm doing is simplifying. So this is 1 times 2x to the 3rd power. Now be really careful when you're doing stuff to the 3rd power. This is not just 2x to the 3rd power. You're going to have to raise 2 to the 3rd power also. So 2 to the 3rd power is 8. So this is going to become 8x to the 3rd power. Okay. Now the key here to not making any mistakes is make sure you just simplify one piece at a time. So this will be 3. 2x squared is going to become 4x squared because you have to raise your 2 to the 2nd power and then times 4. Okay. Here you've got 3 times 2x times 4 squared, which is 16. Okay, and then 1 times 4 to the 3rd power is 64. Just like that. Okay. All right, so my final answer is 8x to the 3rd plus, let's see, 3 times 4 is 12, times 4 is 48, so 48x squared. 3 times 2 is 6, and 6 times 16, failure as a math teacher because I can't do that in my head, 96, so 96x. And then your last one is just 64 times 1, so 64. There you go. That's your final answer. Okay? So I promise you'll get a little bit faster at those as you practice. Just go slow and your first couple of times and make sure that you don't make any mistakes, especially with your exponents. Okay? So that's Pascal's triangle. All right, dividing polynomials. This is actually not that bad either, and I know I say that a lot, but you have to trust me. All right, polynomial, excuse me, long division. What this does is help us find out if some polynomials are factors of others. Okay. All right, so we're going to review simple long division first that you learned in 4th grade, hopefully. So you may not remember it completely, and that's okay. I'm going to go slow for the first couple. So the first thing you want to do is figure out how many times 21 goes into 67. So what would you need to multiply 21 by to get a number as close to 67 as possible? And 21, if you multiply it by 3, you get 63. So that's as close as we're going to get. So 3 goes up here. So then we do 3 times 21, which we already said was 63. And then we have to subtract what's on the bottom. So 67 minus 63 is 4. And then you bring down your 2 to get 42. Okay, then the process starts over. So you ask yourself, how many times do I need to multiply 21 to get 42? Well, you multiply it twice. So then you take 2, multiply it by 21 to get 42, and subtract, you get 0. So your answer is 32, remainder 0. And you'll see why I write it with an R in just a minute. I do that with polynomials too. Okay, so hopefully that makes sense. All right, we can do the same thing with polynomials. Of course we can. All right, so first thing you're going to do is figure out what do you need to multiply 2x by to get 6x squared. So right now I don't care about this plus 1 at all, not in the slightest. I just want to know what do I need to multiply 2x by to get 6x squared. And the answer, of course, is 3x. So I like to write my 3x on top of the other linear term, which is 7x. But if you like to write it down here, not really a big deal where you put it. I'm just a little bit obsessive about the organization. So 3x, we're going to take that and multiply it by 2x plus 1. So this time I care about the plus 1. So basically you're distributing it to the 2x plus 1. So when you do that, it becomes 6x squared plus 3x, like that. Okay, so all we did was we took 3x, we multiplied it by 2x plus 1, and put it down here. Okay, now when we did normal log division, you had to subtract, and when you're subtracting a polynomial, that means not only are you subtracting 6x squared, but you're subtracting 3x also. So that means your signs are going to have to change. So minus, minus, like that. Okay? So 6x squared minus 6x squared is 0, obviously. So if you just want to cross those out, you can. And 7x minus 3x is 4x. Okay? And then pull down the 2, like that. Okay, so now the process starts over. So what do you need to multiply 2x by to get 4x? Well, you multiply by 2. Okay, so we put that positive 2 at the top. Take 2, multiply it by 2x plus 1. You get 4x plus 2. Switch your signs. And you're going to get 0. Because 4x minus 4x is 0, and so is 2 minus 2. So the answer is 3x plus 2, remainder 0. Okay, so your remainder was 0, and that means that 2x plus 1 is a factor of 6x squared plus 7x plus 2. Okay, and that makes sense because if you actually factor 6x squared plus 7x plus 2, like you're used to doing, you're going to find that 2x plus 1 and 3x plus 2 are its factors. So I'll prove it to you really quick. Two numbers that multiply to equal 6 and 2 is 12, and add to equal 7. Those numbers are going to be 4 and 3. Okay, so 6x squared plus 4x plus 3x plus 2. Group those like that. The number that comes out of here is 2x. So we're left with 3x plus 2. And you can only pull a 1 out of here. We're left with 3x plus 2, so your final factors are 2x plus 1 and 3x plus 2. Okay, so what I just proved to you is that when you took 6x squared plus 7x plus 2 and you divided it by one of its factors, 2x plus 1, you got the other factor, and that's why you didn't have a remainder. Okay? All right, so if you'd like to try this one on your own, you can, and then check my work. So if you want to pause the video, maybe not a bad idea. But if not, we'll keep going. So first step, you want to see how many times x goes into 4x squared, or what you need to multiply x by to get 4x squared. So you would need to multiply it by 4x. Okay, so we're going to multiply 4x by all of x plus 5. We're going to get 4x squared plus 20x. Okay, then of course you need to subtract, so change your signs. Okay, so 4x squared minus 4x squared is 0, and 23x minus 20x is 3x. Pull down your negative 16. Okay, so then what do you need to multiply x by to get 3x? Well, you need to multiply by 3. Okay, so 3 times x plus 5 gives me 3x plus 15. But make sure you switch your signs. Okay, so 3x minus 3x is 0, and negative 16 minus 15 is negative 31. So your answer is going to be 4x plus 3, remainder negative 31. Okay, so if I had asked you, is x plus 5 a factor of 4x squared plus 23x minus 16, your answer would have been definitely not. Okay, because you have this remainder of negative 31. This time your remainder was not 0. Okay. All right. This time they asked you, is x squared plus 1 a factor of 3x to the 4th minus 4x to the 3rd plus 12x squared plus 5? Okay, and said be super careful about missing terms, right? You're missing terms in here. You don't have a term that just has x to the first power either in your what's being divided or in the divisor, right? You don't have an x term in here either. So you got to be really careful about that. So here's what's going to happen. We're going to put x squared plus 0x plus 1 outside. And we're going to put 3x to the 4th minus 4x to the 3rd plus 12x squared plus 0x plus 5 right here. So make sure you're not missing any terms at all. Okay? All right. So first step, what do I multiply x squared by to get 3x to the 4th? Well, I multiply it by 3x squared. So then I'm going to take 3x squared and multiply it by everything in here. So that's going to give me 3x to the 4th plus 0x to the 3rd. And 3x squared times positive 1 is 3x squared. All right, switch all your signs. So you'll end up getting negative 4x to the 3rd down here. And 12 minus 3 is 9, so 9x squared, like that. And then I need to pull down my 0x. Okay, so then the process starts over. X squared, how many times do you multiply to get negative 4x cubed? Well, you multiply it negative 4x times. So negative 4x times all this is negative 4x cubed plus, or you can put minus 0x squared and then minus 4x. Switch all your signs. So this time you get 9x squared plus 4x. Pull down your 5. Okay, so last time around the block. What do you multiply x squared by to get 9x squared? You multiply it by 9, of course. So we multiply 9 by all this, and we get 9x squared plus 0x plus 45. Change all your signs. Okay, and you're going to get 4x. 5 minus 45 is negative 40. Okay? So your final answer is going to be 3x squared minus 4x plus 9, remainder 4x minus 40. Okay, and the reason I knew I couldn't keep going is because there's nothing I can multiply x squared by to get 4x. So it was a lost cause at that point. All right, synthetic division, you're going to like this because it is a little bit easier than long division and it's a lot faster. So it's a simple tool, but you can only use it when what you're dividing by, sorry, dead pin problems, what you're dividing by has a leading coefficient of 1, and it's a binomial. Okay, so it's going to look like x plus 2, or it's going to look like x minus 4, or it's going to look like x minus 9, or it could be x plus 1,000. It doesn't really matter, but it just needs to start with x and have no coefficient in front of it. Otherwise, it's not going to work. Okay, so first step. We're dividing x to the third minus 14x squared plus 51x minus 54 by x plus 2. So we're going to set x plus 2 equal to 0 and solve for x. So that means x equals -2. So this is what I'm going to affectionately call my box number. So we're going to put that, that number in a box in the upper left corner right here. Okay. And then I'm going to write all of my coefficients next to it. So I've got 1, -14, 51, and -54. So I'm going to write those down. 1, -14, 51, -54, like that. Okay. Leave yourself some space underneath and draw the line. Okay. All right. So your first step is to pull down your 1 right here. Okay, then this is where your box number comes into play. So you're going to take 1, multiply it by -2, and put that number right here. So 1 times -2 is -2. And -14 plus -2 is -16. So with all these numbers in here, you're adding. Okay, then the process repeats itself. So -16 times -2 is 32. 51 plus 32 is 83. All right, then 83 times -2 is -166. And -54 minus 166 is -220. Okay, so these are the numbers you get. Now, this number, this last number is always the remainder. So your last number, whatever you get, is always your remainder. Okay. And you kind of work backwards from there. So this is going to be your constant term that doesn't have an x with it at all. This is your x term, and this is your x squared term. So we kind of worked backwards. So your answer is going to be x squared minus 16x plus 83, remainder -220. So if I asked you if x plus 2 was a factor of x cubed minus 14x squared plus 51x minus 54, your answer would, again, be definitely not, because you had this giant remainder of -220. Okay? All right, same process again for the U-try problem. So x minus 7, if you set that equal to 0, then you get x equals 7. So that's your box number. And then here, you have missing terms again, right? You don't have an x squared term, so you have to be super careful here too. You have a 1, but you need to put in a 0 for your x squared term. -57, and then we have 56 right here, so I'm going to jam that in there. All right, drop your 1 down. Multiply it by 7 and put that here. 0 plus 7 is 7. 7 times 7 is 49. -57 plus 49, make sure I don't mess this up, is -8. -8 times 7 is -56. And look at that, 56 plus -56 is 0. So this time I don't have a remainder. So again, this is my constant term, my x term, and my x squared term. So my answer is x squared plus 7x minus 8, remainder 0. So this time, if somebody asks me, is x minus 7 a factor of x cubed minus 57x plus 56, my answer would be absolutely it is, because I don't have a remainder. Okay? All right. Here we go. Little application. The polynomial x to the third plus 7x squared minus 38x minus 240 expresses the volume in cubic inches of a shadow box. What are the dimensions of the box? The length is greater than the height. Okay, so we know that volume is length times width times height, right? And they gave me Well, they gave me nothing except the actual equation, right? But what I can do with that equation is see that, and put it in my calculator. So x to the third plus 7x squared minus 38x minus 240. All right, here we go. So you can see that your graph crosses at 1, 2, 3, 4, 5, 6. You know it crosses at 6. So you automatically know one of your factors is x minus 6, right? Okay, sorry guys, I'm back. So you know one of your factors is 6, and so you can divide using the rest of your coefficients. So I'm going to put 1, 7, negative 38, and negative 240 here. Okay, so we're going to drop our 1 down. 1 times 6 is 6. 7 plus 6 is 13. Start using a calculator. 13 times 6 is 78. Negative 38 plus 78 is 40. And 40 times 6 is 240. So I add those together and I get 0. So my answer is going to be x squared plus 13x plus 40, remainder 0. So if you wanted to get your other two factors, all you'd have to do is factor this. Okay, because this represents, let's say x minus 6 was your length. This represents your width times your height. So to get your factors individually, you're just going to have to factor this. So two numbers that multiply to equal 40 and add to equal 13 are going to be 8 and 5. So your final factors are going to be x plus 8 and x plus 5. And it doesn't matter which one's the width and which one's the height, whichever you decide. Okay? All right, very last thing, the remainder theorem. This makes life easier. So if you divide a polynomial by x minus a, kind of like x minus 4 or something like that, the remainder is going to be p of a. So it's just going to be that number plugged in, okay? So if I want to find out if x minus 3 is a factor of p of x, all I have to do is set x minus 3 equal to 0, so x equals 3, and then plug 3 in, okay? All right, so p equals 3 to the 5th power minus 2 times 3 to the 3rd power minus 3 squared plus 2. All right. Good old calculator's going to do this one for me. Minus 2 times 3 to the 3rd power. Ooh. 3 to the 5th power minus 2 times 3 to the 3rd power minus 3 to the 2nd power plus 2. And I get 182. Okay, so that means this is my remainder. So if my remainder is that huge, then obviously that means that x minus 3 is not a factor. Okay? All right, so I'm going to leave you to do the you-try on your own because I am running out of both time and camera space. But if you guys have any questions, come see me next week. I'll be after school most days, I believe, so look for an email from me, and then feel free to take the test anytime you want, but please take it as soon as you possibly can. We start Unit 4 on Monday, so hope you have a great rest of your break, and I will see you then. Bye.